welcome to part 4 of the LinMot AOP AOI integration. We will run an example of a lifecycle test or an assembly process. Once we are online with the PLC, we will need to switch on and home the motor, using the same AOIs we used in parts 1, 2, and 3. In the bottom right corner you will see the test rig. We have the LinMot motor opposing a LinMot football being held in a tabletop vise. The goal is to simulate wear on this foam football by applying a 22 Newton press or about 5 pounds of force. Once homing is complete, we'll jump down to the new subroutine I have created to simulate this sequence. Here we have a state machine tag, and as we add the first value, the first move is executed. Once that move completes, we move on to the next step. In our case, writing a reduced current to the LinMot motor. Let's check the location of this value within LinMot Talk. I can access this drive over Ethernet by inputting the IP address or scanning over the same subnet. Once we have logged in, we can search the UPID we found in our PLC code, 13A6, and see that it represents maximum current for the motor. We can watch this value update as the command to decrease or increase current is received. These values can also be found under the variable section of the drive. Back in the ladder logic, we can see how the duration of that press is determined. We're comparing the motor's actual current to a range of values and then making sure that's held true for more than 250 milliseconds. We also have an MAIAP block, which stands for Increment Actual Position, and that reduces the backlash we've picked up from this press move. Then the motor current is returned to its maximum value of 8 amps and sent back to the 0 position. The last rungs of this sequence are designated for error handling. For example, when the vise becomes dislodged and the motor can't reach its end position. Once I reset this vise, we can return to testing the football. Lastly, we will return to LinMot Talk and watch this same sequence play out on the oscilloscope. I've preset the oscilloscope to start as we pass through 10 millimeters in our stroke, which you can see the blue line of the demand position extend upwards, the red line representing our actual position, and as the difference position grows in green, you'll notice that the demand current holds steady at that 1 amp, which we set through that UPID. At the end of the sequence, you can see the demand position incremented by 0 to match the actual position. You'll also notice the reaction of the football pressing on the motor and causing a slight deviation in current. Thanks for watching this LinMot integration series.